Where we ended yesterday. We had completed the concept. Now we'll practice some numericals based on that. The first one is sine of 71 pi by 2 plus theta. Let's quickly revise what we studied. The topic which we studied was that on the horizontal axis, on the right hand side, that is positive x axis, the angles will be 2 and pi, that is even multiples of pi. On the negative x axis, the angles are going to be 2n plus 1 pi, that is odd multiples of pi, which can also be written as 2n minus 1 pi. If I am talking about the vertical axis, that is when the angle is going to be 4n plus 1 pi by 2, which can also be written as 4n minus 3 pi by 2, or I can, and if I am talking about negative y-axis, then on the negative y-axis, the angles are going to be referred as 4n plus 3 pi by 2 or 4n minus 1 pi by 2. So remembering what we studied, I am going to solve this question. Sine of 71 pi by 2 plus theta. First let's analyze this part, which is 71 pi by 2. If it is a multiple of pi by 2, that means this angle is going to lie on the vertical axis. If I am writing 71 pi by 2, I can even call it 72 minus 1 pi by 2. 72 is a multiple of 4, so I can write it as 4n minus 1 pi by 2, which is symmetric to 4n plus 3 pi by 2. So 4n plus 3 pi by 2 or 4n minus 1 pi by 2 means 71 pi by 2. And as we have mentioned over here, this angle brings me to this point. Excuse me. If I am at this point, then I am adding theta to it. What is theta? Theta is an acute angle. So if an acute angle is added to this point, I enter into the fourth quadrant. In the fourth quadrant, now I have to calculate sine of this plus theta. Since it's a multiple of pi by 2, so sine is going to get converted to cos. Sine will get converted to cos. I'm going to put theta over here. So now sine 71 pi by 2 plus theta, because of it being a multiple of pi by 2, sine converts into cos. I'm going to say cos theta. And because I'm in the fourth quadrant where the LHS, that is sine, is negative, so I have to put a minus sign in front of it. So sine of 71 pi by 2 plus theta is equal to minus cos theta. Let's move forward to the next question. Okay, cos of 11 pi minus theta. Now if I want to convert this, I again have to use the concept which we studied in the last lecture. If it is 11 pi, that means an odd multiple of pi. Odd multiple of pi can either be written as 2n plus 1 pi or 2n minus 1 pi. Odd multiple of pi brings me to negative x-axis. Now if I am subtracting an acute angle from it, if I subtract an acute angle from it, I am going to enter into the second quadrant. If I am in the second quadrant, then let's have a look at the question. Since it's a multiple of pi, cos will remain cos theta. In the second quadrant, what's the sign, SIGN of cos? It is negative. So I'm going to put a minus sign over here. Cos 11 pi minus theta can also be written as minus cos theta. Let's move forward to the next question. Now I have sec of 31 pi by 2 minus theta. Since I have to convert sec 31 pi by 2 minus theta, I'm going to write it as, first quickly revise what we studied. This is pi by 2. Any multiple of pi by 2 will always lie on the vertical axis. If it's lying on the vertical axis, then it can either be 4n plus 1 pi by 2 or 4n minus 3 pi by 2. On the negative y-axis, this can be written as 4n minus 1 pi by 2 or 4n plus 3 pi by 2. Now, if I have to solve for this, I am going to say sec 31 pi by 2 can be written as 32 minus 1 pi by 2 minus theta. So since I have 32 minus 1, this can be written as sec of 4n minus 1 pi by 2 minus theta. 4n minus 1 can also be written as 4n plus 3 pi by 2 minus theta. Now 4n plus 3 or 4n minus 1 multiple of pi by 2 brings me to negative y-axis. If I am at the negative y-axis, now I am subtracting theta, that is an acute angle. If I subtract theta, I enter into the third quadrant. Since it's a multiple of pi by 2, sec will get converted to cosec. It will be cosec of theta over here, and because I am in the third quadrant, sec, cos, they are negative. So I have to put a minus sign in front of cosec, and the answer will be minus cosec theta. I hope that's clear. Let's move forward to the next one. Next topic. Sorry, next question, that is tan of 1072 pi by 2 plus x. Now this is a bit tricky because students start to proceed by just looking at pi by 2 and they assume that this angle is going to lie on the vertical axis. But if we simplify it, then we can see that tan of, if I divide this, what do I get? 5, 3, 6. If I divide the denominators 2 with 1072, I am going to get 5, 3 and 6 pi. So this is 536 pi plus x. This is an even multiple of pi. Let's quickly revise. Where does the even multiple of pi lie? It is on the positive x axis. Since I'm on the positive x axis, if I add an acute angle to it, I'll enter into the first quadrant. So now in the first quadrant, tan of multiple of pi. Since it's a multiple of pi, I will say that tan remains tan of x. Now I'm in the first quadrant, so tan is positive. I'll put a positive sign in front of it. So this expression can be simplified as tan of x. Let's move forward to the next question. Okay, now I have cot of 111 pi by 2 minus theta. If I want to solve this, now let's observe 111 cannot be divided by 2. It will come in decimal. That is the same thing as a fraction. Since I cannot remove the 2 from the denominator, so I'll have to say that this is the multiple of pi by 2. And as we discussed in the previous lectures, any multiple of pi by 2, if I have something like 4n plus 1 pi by 2 or something like 4n plus 3 pi by 2, any multiple of pi by 2, if the denominators 2 cannot be removed, then it will lie on the vertical axis. On the vertical axis, this is 4n plus 1 pi by 2, this is 4n plus 3 pi by 2. Now let's observe how can I write 111 pi by 2. 111 pi by 2 can be written as 112 minus 1 pi by 2. What is 112? A multiple of 4. 4n minus 1 pi by 2 can also be written as 4n plus 3 pi by 2. This is what we discussed in the previous lecture. Multiple of 4 plus 1 is same as multiple of 4 minus 3. This was the example which I gave back then. What is 13? Multiple of 4 plus 1. What is 13? Multiple of 4 minus 3. What is 15? Multiple of 4 plus 3. What is 15? Multiple of 4 minus 1. So 4n minus 1 is equivalent to 4n plus 3. Not equal. They are not equal, but they are equivalent since they are referring to the same point. The values of n in both the cases will be different, so we cannot equate them. But I am saying that they are referring to the same point. 4n plus 1 and 4n minus 3 refer to the same point. So using this concept, I can say 4n plus 3 pi, this is going to be 4n plus 3 pi by 2 or 4n minus 1 pi by 2. Since it is 4n minus 1 pi by 2 or 4n plus 3 pi by 2, I am at the negative y-axis. If I am subtracting theta, subtracting an acute angle, I'll enter into the third quadrant. If I am in the third quadrant, let's have a look at the question. Since it's a multiple of pi by 2, cot will convert to tan theta. Now, what did I get? Tan theta. In the third quadrant, cot and tan are positive. The sign comes from the LHS. Since cot is positive, I'll put a plus sign over here. So this expression simplifies to tan theta. Now let's move forward. Okay, now I have to solve cosec 31 pi plus theta. Let's quickly revise. Negative x-axis is written as 2n plus 1 pi or 2n minus 1 pi. So any odd multiple of pi refers to the negative x-axis. Over here I have 31 pi, that is an odd multiple of pi. Since it's an odd multiple of pi, I am at the negative x-axis. If I add theta to it, I'll enter into the third quadrant. Since we measure positive anti-clockwise direction to be positive, so in anti-clockwise direction it's positive, I'm adding theta in anti-clockwise direction. So I'll move forward in the anti-clockwise direction. I'm in the third quadrant. Since it's a multiple of pi, cosec will remain cosec theta. Now, what is cosec in the third quadrant? It is negative, so I have to put a minus sign in front of it. I hope this much is clear. Let's move forward to the next question. Okay, now I have to solve cot of 41 pi by 2 minus theta. Let's recall the previous maybe second or the third question that we discussed today. If I have a multiple of pi by 2 and the 2 cannot be removed from the denominator. If this 2 cannot be removed, that means this angle is going to refer to the vertical axis. If it is referring to the vertical axis, if it can be written as 4n plus 1 pi by 2, it is referring to positive x-axis, positive y-axis. If the angle is 4n minus 1 pi by 2 or 4n plus 3 pi by 2, then I am referring to the negative y-axis. 4n plus 1 can also be written as 4n minus 3 pi by 2, since they both refer to the same line. Now if I am subtracting theta from it, that means this angle is 41 pi by 2. This can be written as 40 plus 1 pi by 2. This is 4n plus 1 pi by 2. Since it's 4n plus 1 pi by 2, I am at the positive y-axis. If I am subtracting theta, subtracting an acute angle, that will bring me to the first quadrant. Since this is the multiple of pi by 2, cot will convert to tan. Since I am in the first quadrant, the sign of cot is going to be positive, so the answer will be plus tan theta. I hope that's clear. Let's move forward to the next question. The question says tan of 36 pi plus theta. The smart ones might have already answered, but let's try to understand how that answer came. If I'm writing 36 pi, then 36 pi is going to lie over here, since this is the general term for the angles referring to positive x-axis is 2n pi. That is an even multiple of pi. Even multiples of pi will lie on the positive x-axis. Over here I am adding theta. If I am adding an acute angle, I'll enter into the first quadrant. Now a multiple of pi, so tan will remain tan. I will write tan over here and theta over here. If I am in the first quadrant, what's the sign of tan? It's positive. So I'm going to put plus tan theta. I hope that's clear. Let's move forward to the next question. That is cos of minus 30125 pi by 2 plus theta. Let's try to understand what is happening in this question. If I have minus 30125 pi by 2, I can write this term as minus 30124 minus 1 pi by 2. Now this is a multiple of 4, so I'll write it as 4n minus 1 pi by 2. 4n minus 1 pi by 2 is equivalent to saying 4n plus 3 pi by 2. Now let's recall what we have already studied. This is 4n plus 1 pi by 2. This is 4n minus 3 pi by 2. This is 4n plus 3 pi by 2. This is 4n minus 1 pi by 2. So now if I am at 4n plus 3 pi by 2, that means I am at the negative y-axis. From negative y-axis, it is giving me plus theta. So acute angle, I am moving forward by an acute angle in positive direction. What is positive? Anti-clockwise. So I am going to move in this direction and enter into the fourth quadrant. So now it's a multiple of pi by 2. So cot will convert into sin theta. In the fourth quadrant, cos is positive. What do we write? After school to coaching, cos is positive. So since cos is positive, I am going to put a plus sign over here and the answer will be plus sin theta. I hope that's clear. Let's move forward to the next question, which is tan of 10 pi plus theta. This is similar to the one we recently solved of 36 pi. I want you to give it a try. If you have any doubt, feel free to comment. Sir, Urdu mein. I don't know how to speak Urdu. Sorry about that. If you have any doubts regarding maths, feel free to ask. Okay. Okay, it's saying tan of 10 pi plus theta. So now 10 pi is an even multiple of pi. So 2n pi refers to positive x-axis. If I'm at positive x-axis, I have to add theta to it. If I'm adding theta, an acute angle, I'll enter into the first quadrant. So now it's a multiple of pi. Since it's a multiple of pi, tan will remain tan theta. I'm in the first quadrant, tan is positive, so it will be plus tan theta. Okay. Now let's try to solve a question based on this concept, which says cos square pi by 16 plus cos square 3 pi by 16 plus cos square 5 pi by 16 plus cos square 7 pi by 16. The values given inside the brackets are arguments of the function. These are the angles which we are going to input in the trigonometric ratio, and what we'll get is the output. For those who have studied relations and functions, they know that the input is known as domain and the output is the, okay, I'll ask you this question. What is the output? Range or codomain? Please comment. Okay, let's move forward. I have to convert cos of pi by 16 to sine. Now, if I want to convert cos into sine, then the angle should have pi by 2. So, I'm going to add and subtract pi by 2. I'm going to write pi by 16 cos of pi upon 16 plus pi by 2 minus pi by 2. So, now I want pi by 2 to be separate. Only then will I be allowed to convert it. So, I can say that cos of pi upon 2 plus pi by 16 minus pi by 2. So, now I'll write it as cos of pi by 2 plus pi by 16. If I want a common denominator, I'll multiply numerator and denominator by 8 and I'll write 8 pi by 16. This is equal to cos multiplied with pi by 2. This becomes minus 7 pi by 16. So now, since this is a multiple of pi by 2, because it is a multiple of pi by 2, cos will get converted to sine. So I'm going to write sine over here. Theta is 7 pi upon 16. So now I have to talk about what the SIG and sine will be. If I'm at pi by 2 minus an acute angle, that means I'm in the first quadrant. In the first quadrant, the SIG and sine of cos is positive, so I'll put a plus sign over here. So I can say that cos pi by 16 is the same thing as sine 7 pi by 16. So instead of cos square pi by 16, I can also write sine square 7 pi upon 16. I can say sine square 7 pi upon 16. Okay, now let's have a look at this. Okay, now I want to convert cos square 5 pi by 16 into sine. So if I'm writing cos square 5 pi by 16, I want to convert it to sine. If I want to convert it to SI and sine, then I need pi by 2 inside the argument. So I'm going to write, okay, let's simplify the question and I'll only solve it for cos. Then we'll square the two terms and I'll write the value of square in the final expression. So cos 5 pi by 16, if I want to convert into sine, I'll write cos of 5 pi by 16 plus pi by 2 minus pi by 2. So this will be written as cos of pi by 2 plus 5 pi by 16 minus pi by 2. So I'll write cos of pi upon 2. Now again I want to make common denominator. For those who are comfortable, you can go ahead and solve this question and put the answer in the comments. Okay, so now I'm having 5 pi by 16 minus 8 pi by 16. So if I simplify, I will write it as cos of pi upon 2 minus 3 pi by 16. Since it's pi by 2, cos will get, because of pi by 2, cos will get converted to sine. I'm going to write sine over here. Theta is 3 pi by 16, which is an acute angle. So pi by 2 minus an acute angle brings me to the first quadrant. In the first quadrant, cos is positive, so I'll put a positive sign over here. So instead of cos square 5 pi by 16, I can say sine square 3 pi by 16. So over here I'll write sine square 3 pi upon 16. Now let's observe what just happened over here. I'm having cos square 7 pi by 16 and sine square 7 pi by 16. That is sine square theta plus cos square theta. Sine square theta plus cos square theta can be written as 1. Then I'm having cos square 3 pi by 16 plus sine square 3 pi by 16. That is cos square theta plus sine square theta. So that is also going to be 1. So 1 plus 1, the final answer will be 2. I hope that's clear. If you have any doubts, feel free to ask. Else I'll proceed to the next question. Okay. Let's try to solve this one. It's a good question. For those who are comfortable with sigma, you can go ahead and try to solve this question. For those who are not, I'll explain the concept of sigma. If I'm writing something as sigma, r is equal to 1 to 10, and over here I write r, then sigma stands for summation. This means I have to add the values which the r is going to take. R's first value is 1, second value is 2, third value is 3, and so on. It will take till 10. And as you have studied in APGP, the sum of first 10 terms can be given by the formula nn plus 1 divided by 2. So this is going to be 10 into 11 divided by 2. That will be 55. I hope the meaning of this expression summation r goes from 1 to 10 is clear. Okay, now let's try to understand what the question is asking us to do. Summation of r is equal to 1 to 9. So if I want to expand this, I'll write it as sine square. I'll put the value 1 in place of r. I'll get pi by 18 plus sine square. Now I'll put the value 2. So I'll get 2 pi upon 18. Now I'll put the value 3. So I'll get sine square of 3 pi upon 18. Now I'll put the value 4. So what will I get? Sine square 4 pi upon 18 and so on. Finally, the last term is going to be 9. So I'm going to write sine square 9 pi upon 18. 9 pi upon 18 can be written as pi upon 2. Sine 90 is 1. So this expression can be written as 1. Now I have to solve for the first 8 expressions. Let's try to understand what's happening over here. So let's see. If I have sine of pi upon 18 and I want to convert it into cos, how will I write this? I'll write it as sine of pi upon 18 plus pi by 2 minus pi by 2. This will be sine of pi by 2 plus pi by 18 minus pi by 2. This will be sine of pi by 2 plus pi by 18 minus 9 pi by 18. This can be written as sine of pi upon 2 minus 8 pi by 18. Since I have pi by 2 over here, sine will get converted to cos. It is cos of 8 pi upon 18. Since I am in the first quadrant, pi by 2 minus an acute angle brings me to the first quadrant where sine is positive, so I'll put a plus sign. So now sine pi by 18 can be written as cos 8 pi by 18. So instead of this, I can directly write cos square 8 pi upon 18. And over here, the last term would have been sine square 8 pi by 18, because before 9 comes 8. Now cos square 8 pi by 18, that is cos square theta plus sine square theta is 1. So for 1 and 8, I'll get 1. For 2 and 7, I'll get another 1. For 3 and 6, I'll get another 1. For 4 and 5, I'll get another 1. And there was already 1 outside. So I'm going to add these terms. 1 will be added 1, 2, 3, 4 and 5 times. So the final answer will be 5. I hope that's clear. If you have any doubts, feel free to ask. We'll be ending today's lecture over here. I hope you had enough practice. From tomorrow, we'll start the next lecture and I will cover the next topic. Thank you.